Find the equations of the horizontal tangent lines for f of x equals this quotient of two functions. The equations of horizontal tangent lines are when the slope is 0. The slope of any horizontal line in the plane is 0. So this is telling me I need to find the horizontal lines in the plane. Those equations, they're going to be y equals something. That's what the equation of a horizontal line is, specifically for where the derivative of this function equals 0. So I need to find the derivative of this function. I have to use the quotient rule. Bottom d top minus top d bottom over bottom squared. And I want to know where that equals 0. This is the case where I need to do some algebra to clean this function up so that I can determine when its outputs are going to equal 0. So let's clean up the numerator of this function. X squared plus 1 times 1 gives me x squared plus 1. X times 2x gives me 2x squared, and I'm subtracting that, so minus 2x squared. All of that is still over this denominator. Now we're going to take a little sidebar, and we're going to talk about denominators. Never, never, never simplify your denominator. We can determine everything we need to know about this function without simplifying the denominator. Once you simplify the numerator, resist the urge to expand that out, because it's going to be much more helpful for you to leave the denominator in this form. And the more calculus that we learn and the more calculus that we do, you'll come to see that I don't ever simplify the denominator of a quotient. And you'll begin to see why. So let's clean this up a little more. I still need to know where this might equal 0. And so far that's not helping me much. I have like terms. That cleans up to a negative x squared plus 1, still all over the original denominator, and I'm not going to simplify that. Now, any function, even a derivative function, equals 0, I should say any quotient, any function that is defined to be a quotient, equals 0 only when the numerator equals 0. It's the only time any quotient function, known as a rational function, the only time it's going to equal 0 is when the numerator equals 0. Because when the denominator equals 0, this function is undefined. That's not what it's asking for here. Undefined would be a vertical tangent line. The slope of a vertical line is undefined. That would be where the derivative does not exist, where the denominator of a rational expression would equal 0. So the only time a quotient or a rational function is going to equal 0 is when the numerator equals 0. So that's all I'm going to worry about here. It's perfectly fine. Any mathematician that grades your work, AP or otherwise, is going to recognize that it's perfectly fine just to pick up the numerator and set the numerator equal to 0. So let's perform really good algebra. Be really careful. The only x values which I can square and get 1 for an answer are positive or negative 1. Remember, you're going to have 2 answers, not just 1. So here's what I know so far. Let's make a list. Now we know that f prime of x equals 0 when x equals negative 1 and x equals positive 1. So let's go back and read the question and see if that answers the question. Find the equations of the horizontal tangent lines for this function. It didn't say find the x coordinates where the horizontal tangent lines are going to occur on your function. It said to find the equation of the tangent line. So we know that the derivative will equal 0 when x equals -1 and +1. We need to know the horizontal lines on f of x that contain these points, meaning we have to find the y coordinates of these points. We need a relationship between x's and y's. That's what this is. Y equals this function. If I know x values, I can plug them into my function and find the corresponding y values. So y is going to equal x over x squared plus 1, -1 over -1 squared plus 1. That is going to equal -1 over 2. So one tangent line has the equation y equal -1/2. There's one answer. The y for this point is +1 over +1 squared plus 1. That is +1/2. So the other horizontal tangent line is the horizontal line y equals 1/2. So now we have answered the question. The equation of the horizontal tangent lines for this function are y equal -1/2 and y equal +1/2.